Dear students, under the lecture series on complex analysis, we are solving problems under the topic harmonic function and analytic function. In our previous video lecture, we solved problem 1. Now here we have another significant problem. Show that u equal to logarithm of square root of x square plus y square is harmonic and determine its conjugate and hence find the corresponding analytic function. As in the previous question, here also we have to first show that the given function u is harmonic, and then we have to determine its harmonic conjugate, and then we have to find the analytic function. So we have to solve three questions over here. As the first step, let us show that the given function u is harmonic. In order to show that the function u is harmonic, we have to show that the function u satisfies the Laplace equation uxx plus uyy is equal to 0. So now in order to show this, first of all we shall take and write the given function u. So u is given to be logarithm of square root of x square plus y square. Now this can be rewritten as logarithm of x square plus y square to the power 1 by 2. The square root, I have written it as the power 1 by 2. And we know that logarithm of a to the power b will be equal to b log a. Using this, we understand that this 1 by 2 can be written as 1 by 2 logarithm of x square plus y square. So now u is equal to 1 by 2 logarithm of x square plus y square. Now we shall find uxx and uyy using this u. So what will be uxx? Ux is the first differentiation of u partially with respect to x. So 1 by 2 comes as it is, and the differentiation of logarithm of x square plus y square is 1 by x square plus y square, and using the chain rule it has to be multiplied with the differentiation of whatever is here in the bracket. Now a differentiation of x square will be 2x and the differentiation of y square is 0, so we will have only 2x, and this 2 and 2 gets cancelled and we get ux to be equal to x divided by x square plus y square. So let me take and write that. So ux is equal to x divided by x square plus y square. Now using this we have to find uxx. So uxx will be differentiation of ux with respect to x partially. So now we have to differentiate this, for which we have to use the u by v method. So using the u by v method, here we will be having x square plus y square the whole square, and x square plus y square multiplied with the differentiation of the numerator, which is 1, because the differentiation of x is 1, minus x multiplied with the differentiation of the denominator. Now here when we differentiate we get 2x, and then differentiation of y square is 0, and so this will be equal to x square plus y square minus 2x square the whole divided by x square plus y square the whole square. So on simplifying we get what is x square minus 2x square, it will be minus x square. So we can write this as y square minus x square divided by x square plus y square the whole square. So this is uxx. In a similar manner, we have to find uy and uyy. So let us do that. So if you see, we have u here, and so uy will be partial differentiation of u with respect to y. So when we differentiate this, 1 by 2 comes as it is. Differentiation of logarithm is 1 by x square plus y square multiplied with the differentiation of whatever is in the bracket. When we differentiate x square with respect to y, it becomes 0, and the differentiation of y square will be 2y. So 2 and 2 gets cancelled and we get y by x square plus y square. Therefore we see that uy is equal to y divided by x square plus y square. In a similar way, we have to further differentiate this uy to find uyy. That will be equal to, we have to use u by v method. So that will be equal to, when we use u by v method over here, we get x square plus y square the whole square, and x square plus y square multiplied with the differentiation of the numerator. Numerator is y, differentiation is 1. And then minus y multiplied with differentiation of the denominator. For x square it will be 0, and the differentiation of y squared will be 2y. So further on simplifying, it becomes x square plus y square minus 2y square divided by x square plus y square the whole square. And we see that on simplification uyy is x square minus y square, because y square minus 2y square is minus y square, divided by x square plus y square the whole square. So this is uyy. Now we shall add these two, that is uxx and uyy. So therefore uxx plus uyy is equal to uxx is y square minus x square by x square plus y square the whole square, and then plus uyy is x square minus y square divided by x square plus y square the whole square. So we see that the denominators are same. So when we add the numerators, we get y square minus x square plus x square minus y square, and the whole divided by x square plus y square the whole square. So on further simplifying, we see that plus x square and minus x square gets cancelled, plus y square and minus y square gets cancelled, and it is 0. Hence we have shown that uxx plus uyy is equal to 0, which implies that the function u is harmonic. So hence we have proved the first part. Next we shall find the harmonic conjugate of u. So now in order to find the conjugate of u, let us consider, let v be the conjugate of u. So by the definition of harmonic conjugate, we see that if v is the conjugate of u, then the function f of z equal to u plus iv will be analytic. So this is analytic. So it means that it will satisfy the CR equation, that is the function u and the function v will satisfy the CR equation. Now in order to find the function u, in order to find the conjugate v, we are going to make use of the first CR equation. So as per the first CR equation, we know that ux is equal to vy. So we are going to make use of this. So now, using this CR equation, we can write Vy to be equal to, what is Ux? Ux is, we know that Ux we have already found. It is x by x square plus y square. So making use of that, we will have here as x by x square plus y square. So now this is Vy. Now in order to find v from this, we have to integrate on both the sides with respect to y. So integral vy dy will be equal to integral, x will be treated as constant, so we can write this out, and then dy by x square plus y square. Now by the formula of integration, we know that integral of dt by a square plus t square. The formula is given by 1 by a. 1 by a, that is the constant. Then tan inverse of t by a. So from the formula of integration, we know this. Now making use of this formula over here, we see that x is a constant since we are integrating with respect to y. So when x is a constant, it is like a. So x is like a. So therefore x square is a square over here. So when we apply this formula, we get this to be equal to x multiplied with, what is integral dy x square divided by x square plus y square. It is like dt divided by a square plus t square. and so it will be 1 by x, and then tan inverse of, here at the place of t we have y, so y by a is x, so x. So this is what we obtain. And after integration, a constant will be added, and since we are integrating with respect to y, the constant of integration will be phi of x. And so further this will be equal to, this x and x gets cancelled, so that will be tan inverse of y by x plus the constant of integration phi of x. So this is the value of v. So let us mark it as 1. Now we want to get rid of this phi of x. So in order to do that, that is, we have to find phi of x so that we can replace it over here. In order to do that, we have to use the second CR equation, for which first we have to find Vx, which is obtained by differentiating equation 1 with respect to x. So when we differentiate tan inverse of y by x, we know that the differentiation of tan inverse is 1 by 1 plus y by x the whole square, and multiplied with, we have to differentiate whatever is there inside the bracket using the chain rule. And if you see, y will be constant, so it will come as it is, and the differentiation of 1 by x is minus 1 by x square. So we have written that, because we know that the differentiation of 1 by x, on differentiation it will be x power minus 1. So on differentiating it will be minus 1 x to the power minus 1 which is minus 2, and so it will be minus 1 by x square. So using this I have written here minus 1 by x square, and y is a constant which has come as it is, plus we have to differentiate phi of x, so it will be phi dash of x. Now using the second CR equation, we know that uy is equal to minus vx. So this is the second CR equation. So you making use of this, so if you see what is uy, we have here uy is y divided by x square plus y square. So we shall substitute that. So uy is y divided by x square plus y square, that is equal to minus Vx. So Vx is, this is what we have obtained. So when we take and substitute, this minus into minus will become plus. So it will be y by x square the whole divided by, in the denominator we have 1 plus y by x square, which can be written as x square, and the LCM will be x square and x square plus y square plus phi dash of x, and further that will be y divided by x square plus y square, and here it will be, this x square and x square will get cancelled, so we have y divided by x square plus y square plus phi dash of x. And from this we see that the value of the value of phi dash of x will be equal to y by x square plus y square minus y by x square plus y square, which is 0. So from this we see that the value of phi of x will be equal to a constant c, since the differentiation of a constant is 0. Therefore, from phi dash of x equal to 0, we have obtained phi of x to be equal to a constant c. Now we shall take and substitute this over in equation 1. So this we are going to substitute in equation 1. So the value of v will be equal to, so what is that? Tan inverse of y by x plus c. So therefore, we have obtained the harmonic conjugate V also. So this gives us the conjugate of U. And the last step is to find the function f of z. So we have to find the function f of z. So we know that f of z is equals to u plus iv. We shall take and substitute the value of u and the value of v over here. So therefore f of z will be equal to, what is the value of u? We know that u is equal to, if you see here, the value of u is logarithm of square root of x square plus y square. So we shall substitute that. So logarithm of square root of x square plus y square plus I multiplied with v. V is tan inverse of y by x plus ic. Now we know that this is actually log z. Either you can leave the answer as it is, or you can also further simplify it as log z plus ic. So both answers are acceptable. So either you can leave it as it is, or you can replace this by log z, since we have already seen that the value of log z is log square root of x square plus y square plus I tan inverse of y by x. In one of the problem we have seen that. So it can be either log z plus ic, or you can have the answer as it is. So therefore this is the required analytic function. So I hope you would have understood this problem. Kindly follow the upcoming video lecture for more problems under this topic. Thank you.